Welcome back to The Explainer. You know, we love to peel back the layers on the tech we use every day, and today we're tackling a big one.
Have you ever really thought about that? How that little buzz in your pocket happens? Today, we are diving deep into the hidden world of notification systems, the engine behind every single alert, message, and update you get.
All right, so first things first. To really get this, you got to understand that not all notifications are the same. It's not just one thing. We're really talking about three core channels. You've got your push notifications. Those are the alerts from your apps that pop right up on your screen. Then there's the classic SMS message, for really important stuff like two-factor codes. And of course, good old email. Believe it or not, the engineering journey each of these takes to get to you is completely different.
Okay, so sending one notification? That's easy. But that's not the real world. The real challenge, the real problem to solve here is scale. We're talking about mind-boggling volume.
Just try to wrap your head around this for a second. A big service, like a major social media app, might need to send out 10 million push notifications every single day.
And that's not all. You can add another 5 million emails to that pile. Think about all the receipts, newsletters, marketing messages you get.
And then, on top of that, throw in a million SMS messages. And these are often these super critical ones, right? Like your login codes. The numbers here are just huge.
So that's the real question, isn't it? How on earth do you design a system that can handle all of that traffic day in and day out without just collapsing? And not just handle it, but do it reliably so nothing ever gets lost.
Okay, so if you were tasked with building this, where would you even start? Well, you'd probably begin with the simplest, most straightforward plan you can think of. Let's walk through that first attempt.
The first idea is, hey, let's just have one big server that does it all. A service sends it a request, the server figures out the message, connects to Apple or Google service, and just sends it. Seems logical, super simple. What could possibly go wrong?
Well, turns out a lot can go wrong. This super simple design has some absolutely critical fatal flaws. For one, it's a single point of failure. If that one server goes down, boom, the entire system is dead. No notifications for anyone. And if one type of message, say a big email, is slow to process, it creates a traffic jam holding up everything else behind it. This design is basically a ticking time bomb at scale. Okay, so that first plan is a disaster waiting to happen. This brings us to a much smarter, much more robust way of thinking, and it all revolves around one powerful concept, decoupling. Basically, breaking things apart.
The secret sauce here is something called a message queue. The best way to think about it is like the ticket line in a busy restaurant kitchen. A waiter doesn't run up to a chef and demand a steak, right? No, they put the order ticket on a rail. The chefs then grab the next ticket whenever they're free. This queue acts as a buffer. It completely separates the person taking the order from the person making the order.
So let's apply that idea to our system. In this new and improved flow, we create specialists. We have a bunch of servers up front, and their only job is to take in notification requests. They validate it really quickly, and then, this is the crucial part, they don't send it. They just drop that order into a dedicated message queue. One for iOS pushes, another for Android, another for emails. Then you have separate worker servers, our chefs, who just pull jobs from their specific queue and do the heavy lifting of sending.
And that, right there, is the magic of decoupling. Think about it. If the email workers are getting bogged down, who cares? The push notification workers are in a completely different line, pulling from their own queue. They're totally unaffected. If you suddenly need to send way more push notifications, you don't touch the email system. You just add more push notification workers. You can scale each part of the system independently. The bottleneck is gone.
All right, so we've got a fantastic blueprint now. But to take this from good to professional grade, we need to add a few more critical features.
Because a truly great system thinks about everything that could go wrong. Like, what if a send fails? You need an automatic retry system. What if a user clicks a button twice by accident? You need to prevent sending the same alert twice. And maybe most importantly, you have to be user-friendly. You have to respect their choices.
And that respect starts right here. Before a single notification is even created, the system has to do a check. Does this user even want this kind of notification? It looks up their settings. Oh, they've opted out of SMS? Then the process stops dead in its tracks. No message gets created, nothing is sent, no spam. It's that simple.
Now, when you're dealing with millions of messages, you can't build each one from scratch. It's way too slow and risky. So you use templates. You have a pre-written, pre-approved structure, and the system just plugs in the specific details for each user, like an item name or a date. This is how you generate millions of personalized messages in a flash, all while making sure they're consistent and error-free.
Okay, but what happens when things go wrong? Let's say a third-party service has a temporary glitch. You can't just lose that message. A robust system will have a retry mechanism. The worker tries to send, it fails, so it puts the message back in the queue. A little later, another worker will pick it up and try again. Only after it fails, say 3 or 4 times, does it get flagged for a human to look at. This ensures that temporary network blips don't cause messages to get lost forever.
So after all this talk about servers and queues and workers, what's the big picture? Why does any of this deep-in-the-weeds engineering actually matter to you?
Well, it's the difference between an app that feels reliable and one that feels broken. This kind of thoughtful design is why your login code arrives instantly when you need it. It's also why you don't get emails from services you've unsubscribed from. It's all about building a system that is rock-solid reliable and respects your time and your attention.
At the end of the day, what really separates a helpful notification from just more digital noise, the answer is in this kind of thoughtful engineering. The architecture we just walked through is what turns a simple ping into a line of communication you can actually trust. It's the silent, invisible workhorse of the modern internet that, when it's done really, really well, you don't even know it's there.